Hello, General Biology. This is our fifth topic for climate change, carbon dioxide and atmospheres. And this is a long one, so we may have to do this over multiple videos. We'll see how it goes. First, let's talk about the greenhouse effect. And to do that, we need to understand greenhouses. So, how do greenhouses work? Well, they're this glass building that they grow plants in. Well, how does that work? Well, plants need light, and luckily, glass allows light to pass through. So the light passes through into the greenhouse, and the plants can use it. But something happens to light when it strikes surfaces. If it strikes a bright surface, well, then the light reflects. But if it strikes a dark surface, then some of that light is going to not reflect. It'll instead be absorbed and be transferred as heat. So some of that light is becoming heat. Well, it turns out the glass will trap a lot of the heat. So that allows the plants to get light, but it also traps the heat and keeps them warm. Well, it turns out our atmosphere works very, very similarly. Our atmosphere is composed of gases, and some of those gases are what they are called greenhouse gases. And greenhouse gases work just like the glass in greenhouses. Light from the sun passes through, it strikes the surface of the earth, and some of it is converted to heat. And the heat can bounce right back out, but some of the heat is trapped by the greenhouse gases. It bounces off the greenhouse gases and goes right back down to the earth. So that allows us to trap some heat on the earth. This is actually good for the planet Earth because living things need a very particular temperature range in order to survive. And if you don't have an atmosphere, then that range becomes very, very big, like places on the moon where it's there's a huge, huge range between how hot it gets in the day and how cold it gets in the night. And that range is much smaller here, which makes it better for life. So we do need an atmosphere. We need some greenhouse gases to make Earth a place that we can live. But things are changing. Charles Keeling, in 1958, started taking samples of carbon dioxide from the atmosphere in Hawaii. And he noted that in the summer, from April to October, carbon dioxide levels decreased. This was because in the summer there are lots of plants. The plants do photosynthesis. They use the carbon dioxide to do photosynthesis and make glucose. And then basically the plants start hibernating. They lose their leaves. They're not as active, and so there are fewer plants, so carbon dioxide increases in the winter month when the plants aren't active. That's why every single one of these has an up, down, up, down, up, down curve. But he also found that overall, it's increasing. Carbon dioxide in the atmosphere is increasing. Well, after a while, NOAA started helping out, and they also started taking data. So we have Charles Keeling kind of starting this all off. NOAA picked up after him, but there are other scientists involved too. In the Antarctic International Science Research Station, we have scientists from all over the world who come and they dig deep down into the ice to drill out what they call ice cores. And ice cores are these long, basically cylindrical ice cubes that have ice trapped in them. And the farther down you go, these bubbles are all trapped atmosphere from the past, and the farther down you go, the farther back in time you go. And they have been able to drill in certain places to go so deep that they're able to get atmosphere samples from 800,000 years ago. And because they can melt the ice and get the atmosphere samples, they can test how much carbon was in the air for all of those times, 800,000 years ago. And for that entire time, the concentration of carbon dioxide never went above 300 parts per million. That is in sharp contrast to what the carbon dioxide levels are today. Today, the carbon dioxide levels are near 400 parts per million. So this hasn't happened in the last 800,000 years. We have not had an atmosphere like this in the last 800,000 years. Some people say that, well, it's part of the natural cycle of the Earth. Well, it has not been part of the natural cycle of the Earth for 800,000 years. Well, what does it mean that carbon dioxide is increasing and that it's higher than it's ever been? Well, because carbon dioxide is a greenhouse gas, more heat is being trapped, and we are seeing increased surface temperatures around the world. And if we increase surface temperatures, that means more ice melts. So this is responsible for global ice reduction, and global ice reduction and expanding waters are part of sea level rise. And of course, if we have more carbon dioxide in the atmosphere,
CO2 in the atmosphere diffuses into the ocean, causing ocean acidification. CO2 connects all parts of climate change. The video is kind of long. The review will come later. And I hope this helps. Struggle well. Thank you guys. That's so legendary.
Okay.
I'm gonna go watch that video later.
I got captioned it. I got uploaded to YouTube and all that stuff. But
I'm gonna send that to you. I'll be the Atrium Dig Up. Pretty cool.
Alright then.
Yes.
Thank you so much.
Yeah.
Did you have anything?
No, I'm sure you can do that.
Well, we got something done.
Yes.
Have a good one.